Imagine this, a tiny spacecraft, launched back in 1977, now drifting so far from Earth that it's beyond the reach of any planet in our solar system. Voyager 1 is over 20 billion kilometers away, on the very edge of interstellar space. It's seen the rings of Saturn, the storms of Jupiter, and now it's floating in the cosmic abyss. But here's the wild part. It's still talking to us. How, though? How does a spacecraft with technology from the 70s, something built in an era when cassette tapes were cutting edge, still manage to beam signals across such unimaginable distances? The secrets behind this are more incredible than you might think. It's not as simple as pointing a telescope and waiting for it to ping back. Communication with Voyager involves overcoming challenges that test the limits of physics, engineering, and maybe even a bit of luck. So, let's dive in. First things first, what exactly is Voyager's communication system? How do we even start listening to a signal that's traveled billions of kilometers through the emptiness of space? All right, let's start at the beginning. Voyager 1 and its twin, Voyager 2, were both designed to explore the outer planets. But nobody thought they'd be active decades later, let alone transmitting signals from interstellar space. So, how are they doing it? First off, the heart of this communication system is an aging radio transmitter. And when I say aging, I mean seriously aging. It's been operational since a time when home computers were almost non-existent. Voyager transmits its signals back to Earth using an antenna that's about 3 meters wide. This tiny dish is the key to reaching us from billions of kilometers away. But here's the catch. Its power source, a radioactive generator, is gradually fading. So, how does this little powerhouse still manage to be heard across the vast emptiness of space, especially with such low energy? Well, the answer lies in a network here on Earth, something known as the Deep Space Network, or DSN for short. The DSN is a global system of large radio antennas in California, Spain, and Australia. Each of these locations was carefully chosen so that, as Earth rotates, we never lose track of Voyager. When Voyager sends a signal, it's picked up by one of these massive antennas. And here's the part that blows my mind. The signal Voyager sends is incredibly faint. By the time it reaches Earth, it's about 1 billion times weaker than the power needed to run a small light bulb. Imagine trying to listen to a whisper from over 20 billion kilometers away. Yet, somehow, scientists managed to capture this faint signal. And I know what you're thinking. If it's that weak, how do we even detect it? The Deep Space Network's antennas are powerful enough to pick up these whispers because they use what's called signal amplification. Basically, they take that tiny, almost ghost-like signal, and they amplify it, making it strong enough for scientists to decode it. But it's not just about the strength, it's also about the precision. The DSN has to know exactly where to point in the sky, down to a fraction of a degree. Imagine aiming a laser pointer at a coin on the moon. That's the level of precision we're talking about here. Yet even with all this, there's another big challenge: time. Voyager is so far away that a message from Earth takes over 20 hours just to get there, and it takes another 20 hours for Voyager's response to travel back. That means each interaction, each command we send or data we receive, involves a 40-hour round trip. Think about that. In our world of instant communication, waiting nearly 2 days for a response feels almost surreal. But this delay, it actually gives us a glimpse of just how far Voyager has ventured. Right now, it's humanity's farthest reaching messenger. When we communicate with Voyager, it's like sending a message to the edge of the unknown. So, what exactly are we learning from Voyager? Why are we still so invested in hearing from this little spacecraft so far from home? The answer is, Voyager is sending back data on interstellar space itself. It's helping us understand what lies beyond the influence of our sun. And this information is pure gold for scientists. You see, until Voyager, we had no way of knowing what it's like outside our solar system. Voyager 1 crossed this boundary in 2012, and Voyager 2 followed in 2018. Now, both spacecraft are out there, floating in a region that we call the interstellar medium. And this place is unlike anything we've encountered before. Through Voyager, we're learning about the density of particles, the magnetic fields, even the shockwaves from distant supernova explosions. Voyager's instruments, as simple as they are by today's standards, are still recording the conditions of this mysterious environment. It's like a cosmic weather report from the edge of the galaxy. But there's one big question we have to face. How long can this last? Voyager's power source, a plutonium generator, is slowly losing energy. Each year it's able to power fewer instruments, and soon it'll be lights out. We're racing against time because eventually Voyager will fall silent. And when that happens, our longest distance explorer will simply drift forever, a silent testament to human curiosity and determination. Maybe it sounds a bit poetic, doesn't it? This little spacecraft, carrying a golden record of Earth's sounds and images, just sailing through the stars. One day, maybe another civilization will find it. Or maybe it will drift alone for all eternity, a reminder of our attempt to reach the stars. But for now, we still have a line to Voyager. We're still connected. And every faint signal that makes its way back to us is a message from the farthest reaches of our universe. So next time you think of Voyager, remember, it's not just a machine, it's a part of us, reaching farther than we ever thought possible. Now, imagine the end. Scientists predict that by the mid-2030s, Voyager's power supply will be too low to support even minimal operations. Slowly, each instrument will be shut off to conserve energy, until there's nothing left. No more data, no more signals, just a silent object moving through space, carrying the sounds and images of Earth. But in a way, that silence isn't just the end. It's a new beginning. Because Voyager will continue its journey. In 40,000 years, Voyager 1 will pass within 1.6 light-years of a star in the constellation Camelopardalis. It will likely drift past countless stars, forever carrying that golden record with messages from Earth. If another civilization ever intercepts it, what will they think? Will they understand the symbols etched on the golden record? Will they hear our music, our voices, and wonder about us the way we wonder about them? Or will it remain a cosmic mystery, a puzzle to solve in some faraway future? The Voyager mission may one day end, but its journey will go on. It's like a message in a bottle, thrown into the cosmic ocean, with no guarantee of who or what might find it. It's a hopeful message, a way of saying to the universe, we were here, we existed, we reached out to the stars. So, every time Voyager sends that faint signal back to Earth, think of it as the universe reminding us just how far human curiosity has taken us. A tiny spacecraft, drifting in the vast unknown, speaking to us from the edge of interstellar space. Because even as the mission's instruments go silent, Voyager's impact will continue, igniting our curiosity, reminding us that there's always more to explore, always another frontier. And who knows, maybe one day, a new generation will build a spacecraft that goes even farther, reaching places we can only dream of today. Voyager's journey may be unique, but it's part of a much bigger story. The story of human exploration, of reaching beyond the known, of daring to ask, what's out there? So, next time you look up at the night sky, just remember, somewhere out there, Voyager is still traveling, still carrying a piece of us, forever part of the universe, forever part of our journey into the unknown.